Hi class. Today's lecture covers the basics of cognitive and ability testing. This recorded lecture is divided into three parts. The first part introduces the notion of general mental ability and intelligence. The second part covers validity evidence for these tests. And the third part covers adverse impact, other considerations, and other types of ability tests. So for part one, we will begin with a quick history lesson, then dive straight into some examples of cognitive tests. Then we proceed to ask some fairly deep philosophical questions about how people think, which of course have implications for selection. And lastly, we cover the rudiments of testing intelligence, and we cover an exemplar commonly used in selection, which is the Wonderlic personnel test. Now, intelligence is, for better or for worse, one of the most controversial topics in all of social science. Everybody and their uncle has got an opinion on intelligence. Here are some lines. Stop me if you've heard these before. IQ tests just measure how good you are at doing IQ tests. Yep, that's all they are. They have no other value. They're just an arbitrary test, so they claim. Others say passion and emotional intelligence matter more at work than IQ. Where really it's not about talent, it's just about your willingness to push hard and do you understand your emotions and the emotions of others. Another claim is that grit beats the pants off IQ. That's an exact quote from Angela Duckworth, the proponent of grit, which is this sort of hot new construct. It's basically your passion and persistence for pursuing long-term goals, and supposedly it matters more than IQ, and that's the claim Angela Duckworth makes. Others say, well, there are lots of ways to be intelligent, lots of different kinds of intelligence, so what's the point of taking these IQ tests? And lastly, some say, well, I mean, what's the point? Smart people are generally bad leaders anyway and tend to have poor social skills. Now, are these things true, class? Now, whenever you encounter a claim, try to approach it as an empirical question. Let's look at what the evidence says. And so in this lecture, I will present evidence that every single one of these claims is patently wrong. These are all factually incorrect. Now, the funny thing, class, is that they feel right. They feel like they should be correct, but that does not mean that they are correct. So let's get into it with a history lesson. The first cognitive ability tests were used, believe it or not, in 7th century China and through most of the past millennium in China for the imperial examination, which was used to select applicants to work for the Chinese bureaucracy. So this is the earliest recorded example of testing used in selection. This was not really an ideal test since applicants were not tested on their skills relevant to the bureaucracy, but they were tested on their knowledge of the classics in literature in China, among other things, so not really ideal testing. But we do see this notion emerge again in Paris. So in 1908, tests were developed to select streetcar operators in Paris, and these tests measured things like reaction time, which, so for example, if you've ever played this game with yourself and you're standing at an intersection and the light is red and you want to start walking as soon as it turns green. It's like, as soon as it turns green, I'm gonna walk. The quicker you are at getting to walking, that is your reaction time, how quickly you respond to stimuli, which is very useful when you're driving or operating a streetcar. Ability testing and selection really began to boom through the World Wars. In the US, they developed what they called the Army Alpha test, which is a paper and pencil intelligence test that they used to select or reject Army recruits. And this sort of testing began to really proliferate in industry after World War II, and even a bit before World War II. There was a bit of backlash for a while because of worries over adverse impact, which we'll get to in a bit. But that was, historically speaking, a small bump in the road, and now ability tests are in just about every selection process. So here are some examples, class, of cognitive and ability tests. So here's one. Here's a question. When red is X, green is Y. When green is not Y, blue is Z. But blue is never Z as long as red is X. Therefore, which one of these statements is correct? And you have options A, B, and C. Now this seems relatively tricky, but really it's a logic problem. So this is a classic deductive reasoning question. And for those of you who know your symbolic logic, all you need to do is apply what's called modus tollens, which is it's something is only true if the antecedent is true if the consequence is true. So you can rule out a couple of the options, like while green is not Y, red is not X, because we know that if green is Y, red is X, and so by ruling out answers in that way, you're left with the only statement that is correct. It's just simple logic. Here we have a mathematical reasoning type question. Penny bought a puppy and the doghouse for $300. The puppy cost $250 more than the doghouse. So how much did the doghouse cost? Again, should be fairly simple. You should be able to solve that on your own, not too complicated. Here is a harder quantitative ability question, which you can look at in your own time. And lastly, we have here a spatial ability question that asks you to divide this figure into 4 parts of equal size and shape. Try to do this on your own, and if you can't figure it out, maybe approach me after class and I'll show you the solution. Now, these are just a few examples, of course. Others include things like reaction time, like I mentioned earlier, vocabulary, memory, etc. Now, class, we arrive at a deep and consequential question about the structure of cognition, which is to say, the structure of how the mind works. Think about the broad range of mental abilities that we could test. Memory, reaction time, logic, vocabulary, spatial reasoning, quantitative skill, and so on. Now, of course, people vary in all these mental abilities, right? But how do they vary? One view is that some people are good at some mental abilities, while others are good at other mental abilities. This view treats cognition as multi-dimensional, and it views people as cognitive specialists, yeah? Kind of like insects. So, like ants are specialized into, worker ants and soldier ants and queens. Maybe people likewise specialize based on the cognitive skills they're good at. Yeah, makes sense. So let's apply this assumption to the workplace. If people are cognitive specialists, then it makes sense to select people based on the fit between their own cognitive specializations, like are you a memory person or are you a math person, and so on. So whether that fits with the specific cognitive demands of the job. So you match people's cognitive skill sets to the demands of the job. Again, it sounds plausible. An alternative view, class, is that people who are good at one mental ability are likely to be good at all mental abilities. Yeah? So if you're good at memory, you may be good at vocabulary as well, maybe also good at logic. In which case, cognitive ability is treated as a single factor, and people are treated as cognitive generalists. In which case, people are meant to be able to do all these mental abilities well. Now again, if we bring this assumption to the workplace, if we assume that people are cognitive generalists, then it makes sense to select smart people no matter what the kind of thinking needed for that job is. So regardless of whether it's a job that requires a lot of writing or a lot of math, you generally just want smart people. People who are very good cognitive generalists. So these are, again, 2 very different views of how people think. Which of these is true? Or rather, which of these is more true than the other? Because we don't want to be thinking purely in black or white terms, right? But one of these will be more true than the other. Significantly more true. Now, class, this is an empirical question. It's a question that we can answer with evidence. What evidence would you look for? Well, you can start by looking at how all the different cognitive tests that I mentioned so far, how do they correlate with each other? That should show us the underlying pattern of whether we are cognitive specialists, in which case related cognitive abilities cluster together but don't really correlate with anything else, or if we're cognitive generalists. Let's see what the evidence shows. Well, class, consistently, time and again, it's been literally over a century of research on cognitive testing. All these cognitive tests correlate with each other. It's remarkably consistent across culture and even across species, class. All these cognitive ability tests correlate. And so you can see that memory would correlate with reaction time would correlate with, say, knowledge would correlate with vocabulary. Now you can take all these correlations and put them together kind of like a mosaic, or like a mat or something, and you can call that a manifold, where it's not just one thing correlated with another thing, but all these things correlated with each other. So there is this positive manifold that underlies intelligence, class. Which means that if you're good at spatial reasoning, you're probably good at reaction time too, and you probably have a good memory. People are unequivocally, they are cognitive generalists. Now, of course, this is extremely counterintuitive. We all believe, or at least want to believe, that we're good at some things and bad at other things. That other people have different talents than we do. Of course, that is still true. Nevertheless, the fact remains that the similarities far outweigh the differences. People good at one cognitive ability are still highly likely to be good at other abilities. And so that means, class, that you can assess how good people are at all these cognitive tests by extracting the common factor underlying all these tests. We call that factor G for general. And in selection settings, we refer to G as general mental ability. Now, class, general mental ability, or GMA, captures a broad range of cognitive abilities, including math knowledge, arithmetic reasoning, word knowledge, and so on. You can also cluster these into second-order factors, like quantitative aptitude, verbal aptitude, technical aptitude, and so on. But underlying all of this is general mental ability. Now let's revisit the earlier premise about selection, which is, should we choose people who have the specific cognitive abilities for the job that match what one does in that job, or should you just select smart people? Now, early on, class, the assumption in HR was that, well, people are cognitive specialists, so perhaps the best way to select people for a job is to identify, well, what are the cognitive skills we need to do this job? Do you need a lot of math? Do you need a lot of writing skills? So on, right? And then test for those skills. Now, believe it or not, this approach has proven to be less effective than just assessing how smart workers are in general. Now, of course, the solution generally lies somewhere in the middle. You don't only want general mental ability, but you certainly don't only want specific abilities either. You kind of want a mix of both, and I'll cover how that might look as we proceed with the lecture. But by and large, class, most of the predictive validity of these cognitive tests is carried by general mental ability, which is to say, that's the bit that really predicts performance. So here are more examples of some specific mental abilities you can test. You can look at these at your leisure. Once again, general mental ability underlies all of these abilities, in which case being good at one increases your likelihood, generally speaking, of being good at them all. Now, when we score general mental ability tests, we come up with what's called IQ, or the intelligence quotient. Well, why quotient? Well, roughly a century ago, these tests were used initially to assess children's cognitive abilities. And so on the basis of children's performance on these cognitive ability tests, they would derive the mental age, quote-unquote mental age of these children, and then divide the mental age by their actual age. So like, someone being as smart as a 12-year-old, but they're only 8 years old. And so you can get that quotient, scale it to 100 to get the intelligence quotient. Now, we don't do that anymore. It makes very little sense to say, yeah, well, I'm 21 years old, but actually I have the intelligence of a 26-year-old. That's bizarre. But nevertheless, the name has stuck around. The label intelligence quotient. So, the IQ reflects general mental ability. And the way it is scored, class, is by comparing people's performance on these tests to norms, which are statistics that show the average performance and the average and the dispersion of performance from a large sample that was studied when the measure was developed. So with IQ tests, the mean is generally centered around 100, with a standard deviation of 15 or 16, depending on the test. So assuming a standard deviation of 15, we can make sense of the chart over here, which is that most people would score between an IQ of 85 and 115, which is roughly average, within a standard deviation from the mean. People with IQs of about 130 are 2 standard deviations from the mean, and if you're between 115 and 130, you'd be considered above average. If you're over 2 standard deviations from the mean, you'd generally be considered exceptional or gifted. You may be able to join a high IQ society, whatever, right? So generally, you can get a sense of a person's intelligence by seeing how far they are from the mean in terms of standard deviations, and gifted people are 2 standard deviations above the mean. There are also people who are below the mean, and you can assess how far they are below the mean using standard deviations as a unit of measurement. So let's look at an exemplar here, class. One example that is still used is the Wonderlic. It's a fairly old test, but still very popular. It's used in personal selection in a broad range of settings, even to select players for the NFL, which is the sports league for American football. This test covers things like vocabulary, reasoning, logic, arithmetic, and generally, it's mostly verbal comprehension stuff and slightly less quantitative stuff. There's a lot of norm information for this test, and so you can see how well how high your IQ is relative to other people of similar education, other people who've applied for similar positions, where in the country, gender, age, ethnicity, and so on. So there are norms for each of these categories. And the test-retest reliability class is roughly between 0.82 and 0.94. Now, to refresh your memory, test-retest reliability refers to how your score on this test now correlates with your score on this test at some point in the future, whether it's a month, a year, or so on. And the correlations are pretty high. They're close to +1, which is the ceiling for correlations. That's as high as it gets. So doing well on the test now means you'll likely do well on this test several weeks later. Here are some example items not taken from the test, but that are similar to what you'd expect from the test. So we'll go through a couple of these. Which of the following months has 30 days? Alone is the opposite of joyful, together, which is the next number in the series, where you have to work out which number comes next. And so on, class. Lots of items like this. And so, that is it for part 1. Feel free to take a break now, and when you're ready, scroll down LMS and begin watching part 2.